In this video, I'm going to go through a common mistake students make when they're doing their analysis of their internal assessment. There's a difference between an exponential decay and an inverse relationship. Let's start by looking at these two graphs. We can see here that in this case, I have a curved line, and yes, it sharply decreases. So does this one. In everyday English, we would use the phrase an exponential decay. But there's a difference between everyday English and actual physics and mathematical relationships that we see happening here. We need to make sure that the only time we use the phrase exponential decrease means the equation has y is proportional to e to the negative x. If your equation does not look like this, you cannot use the word exponential. That's what this one here is. Now, in this case, I can actually use an equal sign because I've used a coefficient here of 1. Over here, though, this is not an exponential decay. This one is actually y equals 1 over x. This one's an inverse. Now, there's a couple things that I can do to look at this to see whether or not one is an inverse or not. If I take this point here, it is 1, 1, which means I have x equals 1 over 1. Yes, that's true. I have another spot here. My x is 2 and my y is 1 over 2. Yes, that is going to be an inverse. Now, I do have the number 1 here in the numerator. It could be a different value, but for all of these inverse graphs, I will have my x value multiplied my y value equaling a constant. In this case, my constant is 1, but it could be any value. So take any 2 points, double check that this is true, and it will be an inverse relationship, where this one is an exponential. So, as I was saying on the previous one, the inverse relationship, we would have x times the y always equaling a constant. That's not going to be true over here. Another thing to look for in an inverse relationship, there are 2 asymptotes, whereas an exponential decay only has 1 asymptote. So one other thing you need to know is how to linearize the graph. In this case, if my graph looks as it's an inverse to start with, then I need to, on my x-axis, instead of x, I'm going to plot 1 over x and leave y here. This should now give me a straight line. For this one, if it is a exponential decay, then I need to do a bit of math here. If I take the ln of this side, ln y, and I get ln of e to the negative x, ln y will be negative x. Because when you do ln of e to the exponent negative x, the exponent comes down. And if I do this, I should get a negative linear line. I hope that helps you know the difference between an inverse graph and an exponential decay. Remember, you cannot use the everyday English of a rapid decrease as an exponential unless we have the natural e in its equation.